Dr. Cheong Wei is the Deputy CEO of the National Research Foundation here in Singapore, which was the organization that granted Singascope, amongst other things, of course, the funding to pursue this national infrastructure level platform. So thank you for taking the time to join us.
I was asked to give all of you a bit of an overview of what we do in Singapore, as well as how we think about the overall sort of like research infrastructure. I think just listening to the talk just now, there's a lot we are still trying to learn as well in terms of how we go about administering it. But it is an area that we have started to think a lot harder about, simply because as our research base grew, and obviously all the equipment started to grow, labs were growing, and after all we realized there were various labs, they were sort of like having similar things, and you realize that not all the equipment was utilized all the time. And of course, you then started wondering how this was maybe perhaps subscale if things were actually combined. I mean, even if you didn't take with the funding, we just combined the funding, whether the facilities would be better, the technical people would be much better in terms of what they did. And so I think that's what started us thinking a little bit harder. So anyway, let me just then go through. I have two parts of my presentation. One is actually just to give you more of an overview of our own sort of like RE ecosystem, our journey of how we got to where we are today. And the second part then a little bit more of our thinking, our approach around the infrastructure, and I guess happy to take in comments and further suggestions of how we can improve it. So the first part, okay, this is a sort of like stock set we tell people about it, but I think the key thing is that from the point in time, you just now saw my CV, you realize that my PhD is actually in economics. I did my chemical engineering, sort of like undergraduate at MIT, and then I was supposed to come back to work for the government, because at that point in time, which was about 1993, when I was sort of like finished my A-levels and go to university, there was no real research happening in Singapore. I looked around and said, okay, if I wanted to pursue a research career, it meant that I was going to leave Singapore and pursue a career overseas, so I chose not to do that. I chose to take out a government scholarship and work for the government. And of course, fast forward, by the time I came back again with my PhD, the research landscape here was actually far more established than it was, but it was too late then to actually change course. But anyway, so where we are today, I think universities are globally regarded. But not just the universities from an R&D perspective, but also from the innovation perspective. I think there is a lot more vibrancy in terms of how innovation is actually taking some of the research outcomes and making them into useful products or useful companies. Of course, this is still a work in progress. We are still learning from many places around the world, but certainly that's something that has actually occurred over the years. The National Research Foundation itself, which is where I'm from, was only formed about 10 years ago with an attempt to look broader beyond research that was very, I would say, industry-oriented. Because if you look at the journey of this over the years, I think I was around here when I was deciding. There wasn't that much. Today it is like 10 times that amount. But we started work around here very much oriented towards trying to support the MNCs who were in Singapore. You look at the history of Singapore, we grew on the back of the technologies that the MNCs brought into Singapore, because we didn't have that much technology in Singapore, but the MNCs brought in their own technology. And of course, what we then started to realize after a while is that in order for us to continue to be attractive to the MNCs over the years, we had to be value adding to their presence here. And so we started doing some basic development work together with them. So they brought in things and then we did some development with them, and that was where the initial things started around disk drives, data storage technologies and so on. But over the years, we have actually sort of like increased the amount of funding. NRF was formed in around 2006, and a huge amount of funding was then given. So you look at this, all this funding was actually working with the industry that was already in Singapore. And actually basically the stuff that we sort of like knew there was interest to do. Here we formed NRF, we gave $5 billion to fund things that no one else had thought was worth funding previously. And of course that started programs around water, for example, which was actually part of an area that was important to Singapore. If you look at the history of Singapore, we fell to the Japanese in 1942 because the British forgot to guard the reservoirs. They kept falling back, so they had more troops, I think 3 times more troops than the Japanese had, but they had no water. Right, and of course, I think their tanks also didn't have any fuel, but that was okay because you were trying to defend the line, but they just didn't have water, so they surrendered. So with that in the back of our mind, 3 years under that sort of like the period, water became something that was of existential sort of like awareness to Singapore. So I guess we developed a strong membrane technology, sort of like capability, And we have been recycling water from wastewater. And of course, people are not comfortable drinking wastewater, although the water is so pure that our semiconductors actually rather use the recycled water because it's so low on ions. But people are still a bit squeamish about drinking, so we pour it back in the reservoir and then we then process the water so people really we're making it dirtier. It just makes people feel a bit more comfortable. So we do that right now. But of course, when push comes to shove, it is actually very, very ultra pure water that can be used for drinking as well. We have actually since used membrane technology as well for the purposes of distillation of seawater. Normally you think of distillation as you heat up, but actually we are using sort of like a membrane and osmotic pressure and so on to actually distill seawater, and from there much lower energy cost and content, and with that we have actually sort of like achieved a certain amount of water sufficiency. So from time to time you might read about disputes in Malaysia over water. It's actually now more of a commercial dispute than a real existential dispute, because actually, if we really had to, we could probably survive. But I think since anyway we have an agreement, we want to make sure that agreement is honored. But technology has helped us to achieve that. But I think beyond that, around 2000, 2006, we also started, I'm jumping forward. Okay, never mind. So maybe just to give you a sense, okay, so from that point onwards, then we started growing our budget. But you will see that it's sort of like tapering off. Partly because if we looked across the different parts of our spending, we are now at about 1% of GDP in terms of what the public actually spends. If you look across most of the countries around the world, that's about where most countries are spending. The UK actually spends a bit less than that, the US also spends a bit less than that, but like the countries like, I'll say, Denmark and so on, they are spending about 1%, Sweden and so on, 1% of public expenditure. Of course, we hope to can catalyze a large part of our private expenditure into the system as well as part of what we do. From 2016 to 2020, we set aside 19 billion. This just gives you a bit of a breakdown. So a large part actually is set aside for health and environmental sciences. I'll talk a little bit more about that later on. But of course, within that, that doesn't quite cover the fact that there is basic research that we give to universities, and that of course includes some biological sciences funding as well. Manpower, which we call, is actually funding for PhD students. So actually that's another huge chunk of funding that potentially all goes towards basic research. So here is actually some basic research, but a lot more directed research as well, based on what the industry might be interested in, but also some areas like genomics and so on, which we believe that we must build our capabilities, and so we've directed some funding specifically into it. Of course, we did all this, and even as we sort of like rolled out the RIE2020 plan, we started being faced with what we call changing realities. What we call changing realities in that, if you look at the pharmaceutical space, there has actually been a lot less spending by the big companies in R&D. There's been a lot more rise of biotechs. When I first encountered that, I was a bit surprised. But after I spoke to a few people, it became quite apparent why that was the case. I don't know whether, I guess most of you are in the bioimaging space, you know, but the MNCs actually started saying that, well, anything that I spend in R&D is considered cost. And my shareholders were punishing me for spending and not necessarily getting a revenue back immediately. Right? So whereas if I invest in a biotech, it is held on my assets as an asset, and until the startup actually fails, it is at least at book value, if nothing else. Right? So it was just a very basic kind of like a accounting framework that made them decide that biotech was actually one way to actually go about doing it. Now, of course, on top of that, actually, you think about it, in the big pharma, the R&D people are salaried people. Whereas in biotech, whatever you get, whatever you discover is not in yours. I think in terms of incentive structure and so on, it also helped to create much better outcomes and outputs for the sector. So that's what caused the shift. And so what I found was that there were smaller R&D teams. There was more sort of what I call corporate venturing, which is that the big corporates investing in startups, and of course stronger partnerships in public R&D as well in the processes. So, of course, even as we sort of developed our overall strategies, we realized that many countries were also starting to use sort of like R&D as sort of like an advantage that they hope to actually use to build. And so within that, we started looking at our own strategies, looking at what we needed to do, given that we are now talking about this new normal of slow, uncertain growth. I think the rate of economic change brought about by technology has been increasing. And also this whole idea that ultimately we do see Asia as increasingly the place where growth is happening. I mean, of course, the base of activities is still very large in the Europe and the G3 countries and so on, but I think the base of what was growing was actually coming to Asia. So within that, we then asked ourselves, what should our R&D program actually try to achieve? What's our RIE strategy in some sense? And I guess one of the areas that we had then rethought a little bit was actually what were the economic clusters or economic sectors that we ought to be focused on. And of course, issues like national challenges around aging and so on were other areas that we thought we had to add more focus on in terms of where we were directing our R&D funding going forward. So I think the whole idea here is that you think about it, we started off R&D very much with economic focus. We then started saying, okay, but that economic focus is also changing, and of course, more importantly, to direct the R&D towards more national priorities as well is another area that we're now going to pay much more attention on. Which then perhaps brings me to the health and biomedical science landscape, because in some sense, the health and biomedical landscape started very much with a biomedical science foundation, but over time developed to have a far more sort of like a health-related perspective in terms of saying, okay, we've started with the basic biomedical sciences, then we started to bring in the clinician scientists as well into the picture, and of course, but with that, we were then still saying, well, but that's still very much products which may or may not see itself being applied into the healthcare system or even into the improvement of health. And as we move towards the next stage, we have actually started to look at, well, how does it actually improve the health of citizens? And of course, with that, and what I say just now around our positioning around Asia, can we look at that as health for Asian genomes that actually have that relevance for the much larger Asian market as well, as Asia gets richer, as the sort of like middle class consumers actually increase in sizing in Asia. So a large part of our work has then been towards that, but we started off very much just looking at building the basic science research capabilities, many of which you will find today still in A-STAR. And there is some history behind that. We had started a lot of our institutes, the basic sort of like biomedical sciences institutes in A-STAR, at a time when there was not much life sciences in the universities. Right, so rather than to get an allergic reaction of trying to start a new faculty in the university, we chose to build institutes outside the universities at that point in time. But over the years, I think by about 2011, with the formation of NRF and so on, the universities started getting a lot more funding. And so today, the universities themselves do have a strong basic science sort of around biomedical sciences as well. And there, A-STAR has been readjusting as well to make sure that they do a little bit more of the translational work, the work that's directed, for example, you might see towards the food and nutrition, the consumer care sort of like sectors, where it uses biological and sort of like medical understanding to actually do work that the industry is actually interested in as well. But of course, that has been a progress over the, I would say, a 20-year cycle that we are now where we are today. And of course, here it wasn't just about the building a strong scientific base, but I think as we grew and more funding was made available, the question was actually how we make sure that efficiency was also there, because you end up in a situation where there were a lot of people who were doing similar things, or at least doing different things around the same thing. Then how do you coordinate that? How do we make sure that the equipment is actually well organized and so on? Just a quick slide about as a result, what are some of the areas of focus that we actually had as part of our current plan. We looked at Asian diseases, 5 areas. You could say it's quite broad, but at least there were 5 areas of focus that we said we wanted R&D to be in. Of course, this whole idea of discoveries from bench to bedside, having what happens at the bedside inform the bench, and having what happens in the bench so motivate changes to how healthcare delivery is actually conducted. And of course, when we first started off our whole biomedical science, the focus was around farm bio, the big pharmas and so on, and maybe some of the medtech companies. We started moving to food and nutrition and personal care as sort of like areas of economic value as well. And of course, actually, as we started looking a lot more about health outcomes arising from the research the research base we've built up around the biomedical sciences, the question of health sciences research was something that we started funding quite a bit as well, which is to say, actually, it's about health. We're not just trying to deliver healthcare, we're trying to deliver health as well. And of course, in delivery of health, you must understand sort of behavioral dynamics. In economics, called behavioral economics in some sense, of how people change their behaviors, choose certain things. You give them you give them a drug, but then they don't take it, and then so everything is actually wasted. So, but how do you make sure that that's actually going to be valuable? And of course, then with that focus, this is what we have today. I won't go through in great detail, but basically there are startups, SMEs. There is farm bio and medtech manufacturing that actually is one of our key manufacturing sectors. Of course, in food and consumer care cluster actually has been built up quite substantively, particularly around for food, the fragrances and the flavors houses are actually all in Singapore, and they are looking at further work with us around synthetic biology that will help them to actually do their fermentation work and so on in a much more effective and efficient way. Of course, in terms of the various clusters, we have Biopolis, which is where you are in. Cambridge is where the university is, with some companies there as well. The Tuas Biomedical Park is where most of the manufacturing is taking place in the west. Science Park is where some of the medtech companies are. Outram is another place where actually all the major sort of like the national health centers are. And of course, these are all the companies which have their HQs and so on, regional HQs and so on actually in Singapore. So that's the cluster we've actually built up. And of course, we do see ourselves as one of the key nodes in Asia around biomedical sciences. And I guess one of the key things that we have actually come to be regarded as well is actually in the startup space in terms of new investments in biomedical areas. So anyway, this is just to say that because for a very long time, people were asking, okay, so when we invested all this biomedical science R&D research funding, where's the outcomes, where's the outcomes, where's the outcomes? So we are getting finally some traction that this is a good place to be growing biomedical startups, and ultimately, as we look deeper into it, it's about the people that we've trained in that process, the people who've actually been part of the whole R&D endeavor in Singapore. Okay, so anyway, that's just to give you a brief, broad overview. I know it's been a bit of a I don't know. You can come and ask me questions later on if you are interested in anything. But I think the key takeaway is that we have built up the biomedical space over the past 20 years. I think we are now in a place where the biotechs are seeing Singapore as a good place to grow from, with the purpose of trying to access the Asian market. And I think we want to encourage that, and we are providing the various support structures to do that. I'll then talk a little bit more about how we look at shared infrastructure, research infrastructure. Now, of course, there are two parts. One is what we consider to be national research infrastructure. And here, national research infrastructure is what we define to be, basically something that's really large and national in nature. And of course, that it serves a community of researchers, meaning that beyond one institution. And of course, I think that's what earlier said. It's also about raising our value as an international partner in cutting-edge research, because if we have some of these facilities, then others will want to come and work together with us. So I think these are all covered earlier, so I won't talk about that. And of course, these are just the 4 areas where we've actually invested nationally to actually make sure that we have that kind of level of connectivity. These two are actually somewhat connected, because this is actually the network that allows for access to the supercomputer at a speed that then doesn't make you lose the value of the supercomputer's computational power and so on. There is a synchrotron light source that we have. We also have a marine science lab that we've actually formed together as a national research infrastructure. One thing that people don't really realize is that there is actually a rich biodiversity in the waters of Singapore, simply because there are so many ships coming from so many places all over the world that dock. They bring with them all the plankton and all the stuff that actually stuck to the hull, and because the waters here are actually nice and warm, and in a way, actually there is that huge biodiversity that we are discovering and trying to actually make sense of and see what we can do with it. Of course, beyond that, as sort of climate change occurs and so on, we're also trying to understand the hydrodynamics of actually what's happening, as well as what's the impact on the sort of like the organisms and so on, actually or even the waveforms and the structures that of physical structures of the underwater environment. And of course, just a little bit more elaboration about how we went from the first generation of the national supercomputer to the second generation, where initially it was something that A-Star together with NTU and NUS sort of like pulled together. But then when we then gave funding this time around to make it a sort of like a national research infrastructure, it was centralized funding that was provided. But similarly, what happens is that we then expect cost recovery from the users of that particular facility. Okay, so then, of course, then it comes to the Singa scope, which is what Graham actually oversees. Of course, as we started looking at the national research infrastructure, we realized that actually there were duplications, as I said earlier on, across different types of infrastructure and equipment. You realize that unless if you had a culture where everyone was sharing right from the very beginning, trying to tell someone that they need to share their equipment is a very painful thing. So I think as Isaac has done actually with the Research Support Center across all of A-Star, where he's actually tried to pull together the resources across A-Star. And that's actually under one single management. Right? And of course, with that, then they have the booking queue systems. Isaac is the guy who's fair and make sure that whoever books for it is not, there's no priority for some guy he likes better and so on. Look, there's a lot of that kind of stuff. So when we started looking at it across the whole HBMS system we have built, we then say, okay, maybe the way for us to go about doing is, I can't dictate as easily the stuff that's already there. But now someone wants to buy something new, right? I can make them pull together at that point in time to say, let's buy something better together. And then with that, create a way for people to begin to get used to sharing the newer equipment. And of course, once they share the new equipment and they gather a community around it, some of the other equipment they actually own, after a while they say, actually I don't mind also sharing it. So it builds that community of trust first, a way of making sure that things are actually, in a way, fairly conducted before the rest of it can be sort of brought into the fold. So that's what we try to do. It's not a lot of money. We put some seeding money in some sense so that we bring together people who already had some equipment, who were thinking of upgrading equipment. And of course, co-funding was actually something that we didn't ask for. Of course, co-funding could be either money that you were already going to spend on the equipment to begin with, but we then made it a little bit more attractive for everyone by saying, okay, I'll put a little bit more money. So actually now, on top of what you could have bought, to collectively together, I actually gave you a little bit more, so it's even better. Right? So those were the incentives we tried to actually put in place, but of course we then asked for cost recovery as a way of sustainability, and we tell them, okay, at some point in time the equipment needs to be replaced, so recover it, build some sort of sinking fund, and then see that as something that allows you to actually go forward with the kind of good infrastructure for good equipment for everyone. So I think that's 7 of these countries have been funded. Singascope is one of them. Just a couple of slides on Singascope, which I think probably we shared earlier on already. So, but anyway, the key here, of course, is that there is various things that are put in place. So the microscopy infrastructure is one, but the database is another one that's actually important. And of course, the human capital, as well as exchange of experience. And of course, with that, I think then we were able to engage a community like this to actually begin to share some of the expertise and help us to also organize ourselves better. And of course, this was actually a key component of the grant. So in a way, we put money, extra money, with the hope that it actually makes everyone else's money work a little bit better, a little bit more efficiently, and give us better bang for the buck all around for everyone involved. And of course, the last part is just to not forget this. I think we should emphasize as well that the human capital, the training of people, how do you go about using it, was actually an important part of that process as well. Yeah. So yeah, I think I will just stop here. And I realize I'm speaking to experts, so I shouldn't go too much longer. But I think we have found this to be a useful experience, and certainly I think as we build up our biomedical R&D space, biomedical R&D space, this will be an important component of making sure that our base is actually working efficiently for everyone involved. Thank you.
Excellent, thank you very much, Wei Yang, for that perspective. I will take one question if there is one. If not, we can take the discussion forward into the sessions later. I don't see any. Oh, I do see it.
What is your expectation as funder, or the most important expectation from Singascope in, let's say, 5 years from now?
I kind of alluded to that. So I think a large part for us was we really wanted to get the community to get used to each other, to actually come together and actually, because we had developed the different parts of our ecosystem over time. So A-Star started first, then the hospitals had their own things, and then the universities had their own sort of like base of the chip being built up. So part of what we hoped to do was to pull together that whole community, get used to the idea of sharing equipment. So I think if at the end of the whole sort of like funding, people come up to us and say, actually we want to do this small, and there's beyond this few equipment that we have now sort of funded, the 7 projects we funded. Others also say, actually for these areas we would like to pull together as well, which will give us more funding. I think that would be in a way success from our perspective. I think that to us was the key thing. It's not so much the efficiency dollars and so on. I think that's part and parcel of what we have to track, but ultimately I think it's that community pulling together that's the most important.